Welcome after the break. We were busy discussing valley climates. Now keep in mind we experience two types of valley climates, one during the day and one during the night. We looked at anabatic breezes, it happens during the day. What happens during the day? As you can see over there, basically the surface heats up. What does air do when it warms up? It rises. Diversions are taking place in the bottom of the valley. How does the slopes heat up? Obviously through the means the winds heats up through conduction. Because of the surface temperature, the air rises. What happens in the middle? We're experiencing a downdraft because there's divergence taking place on the bottom of the valley. And two distinct cells is formed. Then we looked at katabatic winds. Katabatic winds happens during night time. Now, obviously what happens at night time? Temperature cools down. How does it cool down? Because the land is cool and through conduction the air moves over it and cools down, and convergence are taking place on the bottom of the valley. Now we discussed a valley inversion. We experience this usually during the winter months. If we look at the valley inversion, I would like to repeat this process over here, just cleaning over here. It happens during night time when temperature drops and the air from the surrounding areas sinks to the bottom of the valley floor. Now obviously during the day we experience terrestrial radiation. So very importantly, what happens to the warm air? The warm air is being displaced upwards, and this area is known as the thermal belt. And this thermal belt creates an inversion. We've already discussed what's the inversion. It's an increase with temperature with an increase with altitude. As you can see, the temperature is increasing from point B to point A. It's not normal. In the bottom of the valley, a frost pocket is developed, so all the cool air is collected, and as we move up, warmer conditions. Now, like we discussed, this usually happens in settlement areas, especially for farmers. Very importantly, they need to farm frost-resistant crops down on the bottom of the valley who can withstand the cold conditions. And for instance, crop farming that can't withstand it, they will do it on the slopes in these areas. For human settlement as well, I would much prefer living up the slopes where the warm air is than down on the bottom of the valley where the cold air collects. And sometimes we do settle on both slopes because of population size getting bigger. Now, our next topic that we want to discuss with you that plays quite a vital role is aspect. Now, the first time you were introduced to aspect was in grade 10. Now, we know the surface of the earth heats up by insulation. Very importantly, when we look at aspect, north-facing slopes in the southern hemisphere experience direct insulation. Now, what is insulation? We discussed it in the previous lessons. It's incoming solar radiation. Bear in mind, it's direct insulation, it's direct sun rays. Now, the north-facing slopes is facing towards what direction? Towards the equator. So if we move into that direction over there, we have the equator, and over here we have the polar regions. So our north-facing slopes experience warmer conditions. Even though the area that's being heated up, as you can see, is much smaller, it's much more warmer over there. So as a South African, if you want to build your house on a slope, you always need to or preferably on the north-facing slopes. It means you will have natural heating. It will be warmer because of direct insolation. Unfortunately, in our south-facing slopes, as you can see over here, the insulation comes with a oblique angle. Oblique is obviously with an indirect sun rays taking place. Now, the surface that's being affected is much bigger, but not as intense. So it means the amount of insulation it gets, it's a bigger area, but the warmth is not going to be there. So that's important for the type of farming that we practice in South Africa as well. For instance, on your north-facing slopes, you will see that most of the farming taking place is usually your crop farming or cattle farming. Whereas on your south-facing slopes, because it's basically most of the time in shallow areas, we experience more of shrubs and coffee plantations. For example, very importantly, because of more insulation, if we look at the soil over there, it will be more alkaline because it receives more sunlight. And when we look at our soil type on our south-facing slopes, it will be more acidic because they receive less insulation. Now, take this scenario for example. Now, if we look at settlement, for instance, what will happen? Still, we have our valley over here. Now, if you live in South Africa, especially during winter, what do we experience? We experience these cold conditions. The air sinks to the bottom of the valley. What happens with the warm air? It's being forced upwards because of the cold sinking air, creating the thermal belt. Now, very importantly, even to experience warmer conditions during the winter, where do we need to build our houses? On the north-facing slopes. If the farmers want to farm, where are they going to farm? They're going to farm on the south-facing slopes or north-facing slopes, especially crop that's not resistant down in the bottom of the valley because it can create problems. Now, another reason for the settlement taking place up the slopes rather than down the slopes, because if we look at the previous slide, because of the smog that's being created. Now, smog is a mixture of pollution and fog. Now, if we live in this area over there, we won't be affected by the smog that's been trapped below the inversion layer. Now, as you can see, the frost pocket that we discussed, the effects it will have on it. Aspect, very importantly, because we live in the southern hemisphere, we build our houses on the north-facing slopes. Why? Because of direct insulation, warmer conditions. As you can see, the slopes facing towards the equator receive direct rays. Now, the slopes facing the polar regions, oblique rays. Now, already discussed it, the north-facing slopes are warmer in the southern hemisphere. Now, keep in mind, it's vice versa in the northern hemisphere. In the northern hemisphere, which slopes are going to be warmest? The south-facing slopes. Why the south-facing slopes? Because it's facing towards the equator. Now, I've already discussed it with you, the importance of aspect on natural vegetation, human settlement. We discussed it. I'm going to redraw my valley over here. Now, bear in mind, we are in the southern hemisphere. So if I move into that direction over there, I'm going to move to the equatorial regions. Now, our north-facing slopes, there's our north-facing slope, there's our south-facing slope. As you can see, the north-facing slope facing towards the equator. Direct insulation. Small area, but much more heated. If you look at our south-facing slopes, it's almost cast in a shadow. As you can see, preferably we will live on the north-facing slopes instead of the south-facing slopes. But even though it's a valley that's situated, that's got north and south-facing slopes, the best place to go and live is in the thermal belt. Let's say, for instance, the settlement is expanded over there, there's no more places to build over there, people tend to move over to the south-facing slopes, but not in the bottom of the valley, because we experience the frost pockets in very cold conditions and not below the inversion layer. Why? Because of trapped pollution below it. Very important. And this happens, like we discussed, when the cold katabatic breezes sinks. Now, our next topic that we're going to discuss is city climates. City climates got a different climate than rural climates because external factors plays a role over here. So when we look at city climates, we refer to it as artificial. When we say artificial, it means it's actually fake. It's not real. The reason is because of so much human activities that creates warmer conditions than usual. Now, if you look at rural areas, much more natural areas covered with vegetation, and because of the human activity taking place in city climates, it creates an artificial climate. And when I refer to artificial, once again, you can say it's fake or not real. Simply because of all the people living there and simply because of the activities that's taking place. Now, here's a beautiful graph representing urban climates. Now, what is a graph? A graph represents us with information. Now, as you can see, this is an urban profile on your y-axis. It shows you your CBD. Now, let's say, for instance, Johannesburg, for example, is where your tallest buildings are. Is where loads of activities are taking place, and as you move further from the central business district, that's what this term stands for, you're moving to your suburbs, to your residential areas. And just on your outskirts of your CBD, we got our light industries as well. And then even if we move further, commercial properties, heavy industries, then we start moving to the rural urban fringe. We're moving to the green belts that's situated over there. And then we move to rural areas where there's lots of open space. Now, what's important over here, the y-axis is represented by an urban profile, and your x-axis represents temperature. Now, as you can see, 23 degrees Celsius, 24 degrees Celsius. Now, this line graph that you see over there, when you look at it, line graph situated over here, whoops, just forget my color, let me just get a purple color. If you look at the line graph over here, you can immediately see where the tallest buildings are and where the most densely populated areas are. They experience much warmer temperatures. Now, if we go back to the definition, city climates, artificial climates, because of the structures and the activities taking place over there. Now, as you can see, there's much more human-made structures in the CBD and in the commercial and urban areas. Now, very importantly, Great Falls, the activity and the amount of people over there also adds to this urban climate. The amount of cars also add to this urban climate. The amount of electricity that we use also add to this urban climate. And that's the reason, and we're going to look in detail after the break, why these areas over here experience warmer conditions than the surrounding rural areas. I'll see you right after the break.